Great, thanks. Good morning, everyone. My name is Raymond de Jong. I'm a solutions architect at Isovalent. I've been asked to give an introduction on Cilium and eBPF, discuss the capabilities it can do, and there's quite a lot of content we need to cover. I would like to propose that after each section, I'll pause for a bit to allow you to have questions. I'm not sure what your background is. Maybe you already have worked with Cilium or you're new to Cilium. It would be great if you ask questions and give feedback on the topics being presented. With that, let's get started. Let me organize my screen a bit because I'm all over the place with my screen. Yeah, okay, so the agenda. We'll start with Cilium and eBPF, what the core technologies do, after which we'll dive into some of the networking features it provides, such as cluster mesh as well. We'll touch on security, how to reach and develop a better security posture using our observability tools, a bit about service mesh and Tetragon, and then also some time for questions. And I believe there was also some questions on operating Cilium as such. So we can, if there's time, we can talk about that as well. So first of all, Isovalent is the company behind Cilium. Isovalent originated Cilium, and the engineers of Isovalent are also part of the eBPF Foundation. Cilium and both eBPF are open source projects, meaning that everyone can contribute, participate, getting the products better. And Isovalent also has a Cilium enterprise release, which is a hardened Cilium, which is behind the open source Cilium, which is more tested, fixes are backported, which has HA features and more visibility features with Hubble Enterprise, which is a release fit for enterprises, which brings value for those enterprises with those features. So Cilium at its core is obviously a software-defined networking solution for the cloud-native age. So it's a CNI at first, provides obviously connectivity for your Kubernetes clusters across Kubernetes clusters with our multi-cluster solution called Cluster Mesh. Also ability to extend the data plane to an external workload such as a VM or a bare metal, and to provide a single data plane and a single pane of glass for securing your workloads. Network security using Cilium network policies or plain Kubernetes network policies. What's different is identity-based security, which I will talk about later. Provides encryption using WireGuard or IPsec. In terms of observability, Cilium Hubble, our Hubble solution provides metrics, flow visibility, and service dependency, of which we're also going to talk. Now, Cilium is built on eBPF, and eBPF stands for Extended Berkeley Packet Filter. By itself, that doesn't say a lot, but how we would like to explain eBPF is that what JavaScript was to the browser, eBPF is to the Linux kernel. We make the Linux programmable in a very efficient way. And how we do that is that we develop programs, eBPF code, to be run on kernel events. And this can be anything like a process being executed, doing a connect call, opening a socket, a TCP retransmission, or a network device sending a packet. On the right side, this is obviously network-related events. But for example, if we look at our runtime solution for Tetragon, Tetragon is obviously based on processes, files, admin privilege escalation as well. So that nicely complements the networking features as such. So all those all those kernel events are events where we can hook an eBPF program on, where we can do things. So think about the observability part, where a network device wants to send a packet. The packet is being sent. We can hook an eBPF program on that event to collect metrics for that event and to be able to export those metrics to, let's say, Grafana. And this is basically all where Cilium is built on as a technology. You don't have to be an eBPF engineer to run Cilium, because Cilium abstracts the eBPF complexity for you and makes it easy for you to use. That's always the goal of Cilium, to be able to operate the CNI without having too much, without worrying about the underlying eBPF technology. Some of our customers are already using Cilium. If I start with the hyperscalers such as Google, Microsoft, and AWS, if you look at AWS, EKS Anywhere, Cilium is right now the default CNI. Entos from Google or Dataplane V2 is based on Cilium. Under the hood is Cilium. They forked and managed it, changed it for their needs so they can support it. We're also working with Google to extend, if you would like, the supportability of, for example, Cilium Enterprise for our enterprise customers running on GKE, where we and the customer run Cilium, where Google is running, obviously, GKE. If we look at Azure, Microsoft, they are bringing your own CNI. They are developing that, so we can also be supported in the preferred CNI running on Microsoft systems. And all the customers we work with are across different use cases. If you look at Bell, they are a telco. Obviously, they have high performance, low latency requirements. Wildlife is a gaming studio using Cilium Cluster Mesh solution to have a multi-region gaming platform. So different kinds of use cases, different kind of backgrounds, working with Cilium. So this is the 10 miles or 10,000 foot level view, 10 kilometer view. Obviously, Cilium at its base provides networking. On top of that, we have Cilium observability using Cilium Hubble for metrics tracing, service maps, logging, as such. We recently, or already half a year ago, released Cilium Service Mesh, which provides sidecar-less service mesh solution on top of Cilium, providing ingress, authentication, layer 7 traffic management. And Tetragon is our runtime security solution, which nicely complements all the security and observability features we have at the moment. So let's have a look at what it actually does and how it works in terms of networking. If we look at Kubernetes networking, the CNI as such is mostly built on IPVS or or IP tables, which means that if you look at kubeproxy and for east-west load balancing, the IP tables needs to be programmed as such to connect to the endpoints across your clusters. And that technology at scale doesn't seem to be very fit for the high churn and the high number of workloads we can have in Kubernetes clusters. We've seen customers running 500 or more, or hundreds and more nodes, trying to update a service, for example, an application being scaled out, meaning endpoints for a given cluster IP are needed to be added. And at scale, this can take up to minutes, even 10 minutes for IP tables to reload, because it's not a atomic change. The whole IP tables needs to be reloaded. And that's why our eBPF comes around and provides a solution we call like a kubeproxy replacement, which is basically east-west load balancing being tracked through eBPF Maps, where Cilium is effectively being able to update each entry for a given service as an atomic change, and is almost done instantly using eBPF. This obviously at scale makes a huge difference in terms of performance, and especially with high churn environments. So we talk about east-west connectivity, the kubeproxy replacement, making sure that we are able to connect applications and making sure that we keep that as an atomic change as performant as possible. So the eBPF-based implementation is a per CPU hash table instead of the kubeproxy, which is a linear list where all rules have to be replaced as a whole. Also, when you start with Kubernetes on-prem or in cloud, in Kubernetes, there's no load balancing solution provided out of the box, right? So you rely on node port or on cloud integrations, such as in terms of GKE environment, you actually will create a load balancing instance in the Google GKE environment. Well, Kubernetes out of the box doesn't have any production level load balancing solution as such. Cilium does have a load balancing solution based on Metal LB, and we're currently working on Go BGP as well to make it very efficient to run in an enterprise, to be able to advertise service IPs in an efficient way using BGP and provide efficient load balancing using eBPF for both north-south load balancing and east-west load balancing in your clusters. It's also able to support maglev or direct server return technology, and it can run standalone or in a distributed mode. Obviously, in Kubernetes cluster, it will be a distributed kind of implementation, but you can also run Cilium agents standalone on a high-performance bare metal server and do high-performance load balancing, for example, on that server using Cilium. There's a very nice blog post on the Cilium blogs website where someone explains how Cilium is running standalone on their servers to provide a high performance load balancing solution for them, where they get almost line rate performance using Cilium with eBPF. Another very neat networking solution with Cilium is the Egress gateway solution, which is more about outbound connectivity from your Kubernetes clusters. So you may have workloads which need to connect to a physical database, for example, in the physical network, because that's where all the records are stored. That means that in terms of Kubernetes clusters, you don't want to allow the whole pod CIDR or node CIDR range through that firewall in your physical network to the external legacy or external database in your network. That would be a too much open rule, right? You don't want to allow such a big CIDR to able to reach that critical database in your network. If you look at the Egress gateway solution, you can fix that by selecting nodes which are allowed to connect outbound through the external firewall. And what you do is you basically, based on labels, you select nodes using an egress net policy, and traffic from a given pod or given namespace will be forwarded to that node, where that node will do the source netting on their interface and send outbound traffic to the external network, which allows you to only allow that given node or that given set of nodes access to the legacy database. For our enterprise customers, we have an HA solution for the Egress gateway, which means that you can create a gateway group. So a group of nodes based on the node labels, which you allocate for egress connectivity. You can create active nodes in a gateway group or do things like a hot standby. So it's really flexible for designing an egress gateway solution for enterprise customers. Using this gateway group, one of these nodes will be randomly selected for outbound connectivity. And depending on your throughput needs, you can select more nodes providing outbound connectivity. What's key here is that obviously the nodes need to have some kind of IP address which is routable on the external network, configured on the node. And those IP addresses obviously need to be allowed on the firewall to the legacy app or database. So in this example, we see 3 nodes, meaning that these 3 nodes have an individual IP address on the external network, which needs to be allowed connected to the database. If a node fails, using BPF, we can detect it using health checks. So within a second, we can fail over traffic for a given source on the remaining nodes in the gateway group. In terms of platform integration, there are great getting started guides to see how the integration works. Obviously, you can start with Minikube or with kind clusters on your laptop. You can run Cilium on your own cluster, self-managed Kubernetes environments. Perhaps if you're running RKE, we support that as well, or OpenShift. In clouds, Amazon EKS, GKE, or AKS, on our Cilium or docs.cilium.io website, you can find getting started guides to easily install Cilium on those environments as well. In terms of native cloud support, if you look at Amazon, we have basically 2 modes. This is one of the first modes I'm going to talk about. And this is a specific example of how we integrate with Amazon Web Services for EKS clusters. What happens is that the Cilium operator, once you install Cilium on EKS, will be able to read and to communicate with the Amazon API to understand which IPs are available for a given node to be configured for using for allocating on a given node pod IP addresses. And we keep track of that on our Cilium node custom resource definition, and basically allow the Cilium agent to use IPs for pods on a given node and report those IPs on a Cilium node CRD, so we can track that on the node level. And this allows you to run Cilium as a CNI, and also being able to communicate with Amazon to get things, for example, IDs of security groups in Amazon, which you can also use in Cilium as well. So CNI chaining is another way of running Cilium on environments. This means that, for example, the other CNI can do the device plumbing, IPAM, be responsible for routing, where on top of that, Cilium is responsible for all the load balancing, policies, encryption, multi-cluster, and visibility piece. This is not our recommended implementation, because some of our Cilium's features are not supported as such in chaining mode, but at least this can give you some possibilities to have multiple CNIs, or to run on top of, for example, allow Amazon to do the device plumbing, IPAM, and routing, and then have Cilium for the more security-related pieces, or have a multi-CNI solution if you want to use Multus, for example. That can be done as well. But yeah, again, keep in mind that in terms of support, this is a bit less compared to running Cilium as the native CNI on your clusters. Let me pause a bit if there are any questions so far. No? Great. Okay. Let's move on to Cluster Mesh. Cluster Mesh is a very unique solution in terms of CNIs, where Cilium Cluster Mesh makes it possible to run a single data plane across multiple environments, which enables you to leverage usage of Cilium features across clusters. So first of all, this can be, external workloads, external VM or database, where you want to bring that into the Cilium data plane, into your Kubernetes cluster data plane. Can be multiple on-premise clusters, or a connectivity between on-prem to a cloud environment. So for example, you want to provide burstability for your workloads on-prem to a public cloud solution such as EKS, or it can be across cloud providers, or in some cases, it can also be edge cluster kind of topologies, depending on what you need. And what you can then use is on two or more clusters, you're able to leverage service mesh capabilities, load balancing, the identity-aware security and network policy, observability as well, encryption between nodes across clusters, pod IP routing, and overlay networking between clusters, or overlay networking between clusters. What you need to do, though, is you need to obviously provide connectivity between clusters. We create a Cluster Mesh API server, which is provisioned through either a node port, but preferably, obviously, a load balancer, which must be available to listen. Each cluster has read access to each other cluster through that Cluster Mesh API server, so you make sure that you have that connectivity. And from a node perspective, you need to have a node-to-node connectivity. And this is most of the time easy to achieve through some kind of VPN solution between, let's say, clouds, or between your data center and the public cloud. Also keep in mind that if you're considering deploying Cluster Mesh at the moment, we need you to have unique pod-side IP ranges across clusters. This is being worked on as a new feature to remove that requirement, but at the moment it's still the case. And at the moment as well, you need to have the same configuration in terms of routing on your clusters. So either overlay or native routing, but don't mix them together. That's not supported as such yet. So once you've met the requirements, set that up, cluster mesh is running, you can do different things with it. It's very interesting to see what use cases can be used across cluster mesh topologies. First of all, we have the high availability use case where you want to run your applications across clusters and provide a means of failover across clusters when backends fail in a specific cluster. So in this case, cluster 2 backends in cluster 2 are failing, meaning that the backend service is able to fail over traffic to the remaining backends in cluster 1. How this works is that you just create in each cluster, the same namespace, you create a service, simple cluster IP service, and with a simple annotation, you mark it as a global service. And you do that for each cluster, and that will trigger Cilium to advertise each endpoint in a given cluster to the other cluster, right? So each cluster has, again, that read-only visible access to the cluster, and it will learn what backends for a given backend service, for a global service are available, and it will update the eBPF load balancing map to include those services as backends as endpoints, I should say, for that given global service. By default, it load balances randomly, but as backends fail, it is able to fail over to the remaining backends as such. Another use case can be that of shared services. You may have multiple tenants or multiple environments which make use of the same infrastructure or shared services, such as a vault service or DNS or logging as such. What you can do in these cases is create a global service in each cluster, which points to a centralized shared service in your shared services cluster. That helps a lot because you don't want to, or you don't have to maintain that vault service in each individual cluster. So this can be very useful for managed Kubernetes platforms or multi-tenancy Kubernetes platforms to be easily deploy and lifecycle clusters without the requirement to maintain such vault service or logging service in each cluster as well. You just manage it on a shared services cluster, expose the service as global service in each cluster, and you're ready to go, provided you have the network connectivity between the clusters. And a bit similar, but different is stateless versus stateful. So again, the same story is that you may have a stateful cluster where you maintain such a data store service for maintaining state or keeping track of records, or you may have an application which is tracking data for your applications, where the stateless clusters are, for example, edge clusters or small temporary clusters, where you don't want to maintain or don't have the capacity to be able to provide a full-fledged data store service as such. Using cluster mesh, you can then expose the data store service towards those stateless clusters, and the stateless clusters can then access the data store service. And that really helps with, again, lifecycle management of stateless clusters. Super easy to lifecycle or do a rolling upgrade of those clusters without actually impacting availability of the data store service. New feature in Cilium 1.12 is the topology-aware routing, which includes local or remote service affinity. What this means is that, like I said earlier, by default, a global service randoms randomly sends traffic to backends. With obviously across clouds or on-prem to remote clouds, that would be incurring latency because traffic can go through the VPN toward the remote cluster to a given backend. So to make that more smart and more topology aware, we've included the local and remote service affinity features. That means that for a given cluster, you can either prefer local endpoints or prefer remote endpoints. So in this diagram, we prefer local endpoints, meaning that each front end in each cluster will first be sent through the backend service to local backends. And in case of failure, it will be able to fail over to remote backends. So this will only trigger traffic across the VPN connection across towards the different cluster when needed. The other way around is the remote service affinity, where you can configure a backend service to prefer remote endpoints instead of local endpoints. A use case here is that this enables you to, for example, temporarily annotate that service to prefer remote backends to allow you to, for example, do a rollout restart and upgrade of backends in your cluster before removing that annotation again and being able to prefer it locally again as such. So this gives you flexibility in operating and upgrading your applications in a cluster mesh topology. So how does this all work? Through simple annotations. So this is a simple service where we first of all have the io.cilium global service true. This will trigger the service to be a global service. And then you would add an annotation io.cilium service affinity local or io.cilium service affinity remote to prefer local or remote endpoints. Super easy to operate. Once you apply it, Cilium will update almost instantly the eBPF maps and load balance as such. What's also very interesting is that you can now, with service mesh, can combine cluster mesh features and use this topology aware routing to do different things. This is just one example, but what I'm trying to show here is that you can, for example, use service mesh to configure Ingress to attract traffic in a given cluster. Then Ingress can forward traffic to a given service. You can use all related service mesh layer 7 routing capabilities, such as path-based routing or percentage-based routing, depending on your applications. And then cluster mesh can obviously make it available across clusters. So you can combine the two to create a multi-cluster, high available solution driven with Cilium service mesh. This is just one example, but you can also, I don't have a slide on this yet, but you can also, for example, create a new cluster for a new version of your application where you use, for example, cluster service mesh to attract traffic in your cluster and then do percentage-based routing to slowly introduce traffic to the remote cluster with the new version of your application, which ensures that you're not impacting any resources or performance deprecation in the original cluster, and you can slowly see how it's performing in your new cluster. Or you can do rolling upgrades or recycle clusters with percentage-based routing, for example.
Raymond, can I maybe ask a question? You already, maybe you have answered this, but I think many of the things that you depicted before, we could also do with an Istio-based service mesh, just by putting everything on a higher level. One of the advantages, I think, on a network mesh, on a lower level IP routed mesh, is basically that you don't need to go over, let's say, the Envoy proxy. It's much easier, but also in the form, if your backend is, for example, Kafka, and your clients residing in a different cluster need access to all of the IP pseudo ranges because you don't know where, you can't basically box it in over a single IP address. That is one of the advantages with the network mesh, right? Do you have such examples? Is that used in production? Question number one. And question number two, one of the pain points is that in order to get clusters communicating, you need to do a little bit of orthogonal IPAM CIDR range management. Is there an ability of Cilium to basically connect two clusters which, for example, have the same CIDR ranges, that you don't have this overhead anymore? Are there advantages
yes,
there?
so to answer the last question, yes, that's being worked on. So that allows you to once that's released, removes that constraint, right? So it allows you to have overlapping IPs, so you don't have to worry about those IPs pod CIDR ranges in given clusters. That's an upcoming feature for sure.
Very interesting.
Yeah, so obviously Istio has its own use cases and implementation. With Cilium Service Mesh, we bring the Service Mesh solution into the Cilium agent on the node level. That removes obviously the sidecars from for each pod. So and that has huge performance benefits. Bringing the service mesh into the node level, obviously, for your cluster, cross-cluster or cluster connectivity, still remains required to connect, being able to connect across clusters, for example, with cluster mesh, right? So that means that when the service mesh, when the ingress, for example, gets ingress traffic, it needs to forward it, for example, to one or more services, let's say service version 1 or service version 2. With Cilium Cluster Mesh, it doesn't matter so much where that service is, right? If it's in its own cluster or in its remote cluster. What the point is that once you make it available with the global annotation, the service mesh is easily be able to forward it to, let's say, application version 2 service on the remote cluster, without under the hood having to understand how it physically is connected, right? It's just a service and it forwards to its service. And using eBPF, we are able to short that connectivity on layer 4 to that given service on that given node, if you like. Mm-hmm. So I think there are some huge benefits there in terms of complexity and in terms of combining in a smart way those features.
Both features. And I've read somewhere you're actually combining, or you're using Envoy and the Istio kind of, is that correct? So that is, if I install the Cilium open source solution, I basically get Istio inbuilt. Is that
not Istio, but Envoy? Yeah. So
Envoy. Okay.
Yes, Envoy. Yes. Okay. Perhaps I can park this question for a bit because I do have some content on that as well. So
sorry, but I wanted to ask this question. It was on top of my mind before you run into security. Okay.
It's a great question, and it's actually a good segue for security as well, because Cilium was already using Envoy to be able to have the layer 7 security and visibility features to be able to, for example, inspect HTTP traffic. So I'll pause there because that's a good segue into the security example, which I will talk about now. But keep them coming. These are actually very good questions. Happy to discuss.
Also, one more question.
Yes.
Just if I have a cluster mesh with multi-zone cluster, so can I also do some zone-aware routing with Cilium?
So
I have two services, and I want to connect. So from one client to the backend on the other service, but in the same zone where the client is not in the other zone. So
it would rely how you leverage these annotations and where you apply them on. So in these examples, I'm not sure if this makes sense or explains it if I understand it correctly, but
let's say backend 1 is in zone A and backend 2 is in zone B, and also the same for the front end. And so I want to connect to the remote service, for example, in this case, to the backend, which is in the same zone. So I don't want to do traffic between zones.
Okay. So to make it clear, in this example, I'm annotating both backend service as a global service, making sure that they be able to load balance across clusters. And then in this example, I additionally annotate in cluster 1 to prefer remote endpoints. But the cluster 2 in this example will not have that annotation, and it will just load balance randomly, right? So you can, on backend service and cluster 2, you would prefer the local endpoints, for example, by adding the local annotation. You don't have to annotate those services, right? So it depends on how you want to connect things together and what you prefer in each given cluster. So you can mix and match, right? They are not mutually exclusive as such. Does that make sense?
Yes.
Just to build on what Sebastian was asking, if we consider Cilium just for the service routing, so as a kube proxy replacement, and don't talk about cluster mesh, but just look at one cluster, and basically the one cluster spans multiple availability zones. With Kubernetes, there is, with newer releases of Kubernetes, is a notion of topology-aware routing, where basically you can get hints where the backends are located in which zones. However, that pretty much relies on having your nodes spread, or your compute resources spread very evenly across the availability zones. And so the hints are fairly fast being simply removed. How is Cilium handling that? Or is Cilium providing more options to really ensure that if I have a front end here, front end 1, and a back end 1, both residing in the same availability zone, and assuming front end 2 and back end 2 residing in the same availability zone, can I make front end 1 always talk to back end 1 and front end 2 always talk to back end 2 through the service, and only fall back to the other back end when the first one is not available, so that I don't incur cross availability zone traffic?
That's a good question. I need to check that if we have that interoperability with the Kubernetes topology-aware routing. I'm not aware of such thing yet. So I can make a note of that and come back to you.
Okay,
on that,
thanks.
on that topic. Let me make a note here. Cool. All right. Let's move on to security. If we look at security, Cilium is an identity-based security solution, which means that we don't track IPs. We create for each given endpoint a unique identity based on its labels. So each deployment with pods may have one or more labels attached to it, such as role front end or role back end. Those are stored in Kubernetes, obviously, and Cilium is able to track those endpoints using those identities. So, for example, the front end has the role equals front end label, and that unique set between quotes of labels is a unique identity. So multiple pods with the same labels will have effectively the same identity. And this helps a lot because that provides much richer visibility, but also makes it easier to apply security on high churn, high workloads, high number of workloads across your clusters. So the Cilium agent is able to read the identity, and when traffic is being sent from a front end to a back end, using eBPF, we attach that identity, and we're able to verify that identity on the back end if it's allowed or denied, and we can do things with it. We can also observe that identity using Hubble, for example. This is basically under the hood what drives both security and observability with Cilium. Cilium is also API aware or layer 7 aware. And that means that that's also the segue to the Envoy piece, is that we already using Cilium, we're using Envoy in the Cilium agent to be able to inspect on layer 7 traffic. What that means is that beyond the layer 3, layer 4 filtering, we can also do layer 7 filtering. So for example, a front end is sending an HTTP API request to, let's say, the backend on a specific URL. We can inspect that traffic, but we can also create Cilium network policies to secure that traffic. That also applies to protocols such as Kafka, Cassandra, SQL, gRPC. We can provide security on layer 7 using Cilium network policies. So we can not only inspect the port and the protocol and the IP, but we can also inspect on layer 7 the Cassandra packet or the Cassandra content, and only allow, for example, a specific select action on a specific table. Furthermore, we have DNS-aware Cilium network policies, which is important for being accessing external resources without having to track those IPs. A great example here is S3 storage, object-based storage. Underlying IPs of those objects change all the time, and you don't want to allow a whole CIDR range or need to be able to track the IP addresses of such resources in your Cilium network policies. So using DNS-aware Cilium network policies, we can intercept on the agent a DNS query and its response. And based on that, we can make decisions on if that traffic is allowed or not allowed, and forward or drop that traffic. So in this case, we have a policy which allows egress connectivity to the wildcard.mydomain.io fully qualified domain name. And in this case, we would forward it. But you can also drop traffic based on if it's a different URL or based on the Cilium network policy you create. For enterprise customers, we have a solution called the Dns Proxy Ha Solution, which means that if they have mission critical content running in S3 storage, the Cilium agent is configured as being high available by adding a DNS proxy agent, which is able to sync the current fully qualified domain name cache, which is able to have the data plane configured as well, meaning that if either DNS proxy or the Cilium agent is being failed or is being restarted, rollout restart, for example, we still have current connectivity to that S3 storage. So everything which is currently stored or cached as being allowed will remain to be forwarded. Quick overview of matching capabilities. So obviously IP addresses, fully qualified domain names is something I've touched about on pod labels, namespaces, service names, cluster names. On EKS or environments, for example, we can also, by setting that up, there's a specific guide on that you can sync security group IDs and names or VPC subnet names and tags and use them in your Cilium network policies to allow traffic to or from. Cilium also has this notion of logical entities. So everything inside a cluster or outside a cluster, local host, remote host, ingress, world for anything outside the cluster, or local host if things are running on the local host network as such. Those are reserved identities which you can use in Cilium network policies as well for creating and allowing specific traffic flows. I'll pause here for a second. Are there any questions? No? Okay. This identities is also very powerful in terms of Cilium observability, which is built on that. Because if you want to secure your environment, you need a great observability tool to be able to understand the flows in your namespaces and to be able to secure them or prevent them accessing external resources, for example. So Hubble is a solution built on top of Cilium, which provides this observability monitoring capabilities. It has three main parts. First of all, the Hubble UI is a component which allows you to display flows, to allow you to filter based on flows. You get the service dependency map where you can see in a namespace or between namespaces what is talking to each other and which protocols and if that's allowed. For Cilium Enterprise users, we have the network policy viewer, which can read the current applied network policy. And based on that flow, you can, for example, change and export to be applied in your CI/CD workflow. The Hubble CLI is more detailed flow, more troubleshooting, more capabilities in terms of extensive filtering. Also, ability to output it, for example, to JSON, where you can use that to do different things with it. We've seen customers creating Grafana dashboards based on that JSON output, for example. Hubble also provides metrics. So you can enable Hubble Metrics, which exposes all related metrics from both Cilium, Hubble using eBPF to Grafana and Prometheus or other solutions where you can have dashboards to get health or monitoring capabilities for your platform. So Hubble operates against Cilium. So Cilium runs as a daemon set on each node, and the Hubble relay will collect from the nodes data and expose it either to the Hubble UI component or through the API with Hubble CLI or through Prometheus to Grafana to create and get metrics and to see dashboards on how things are performing in your cluster. So the CLI has a lot of detailed flow visibility in terms of what's going on in a given namespace or for a given pod. So in this example, we're observing a specific deployment with the class equals Xwing, and we can see DNS lookups to core DNS. We can see the response. We can see it tries to successfully connect HTTPS to Disney.com. We see the associated IDs in purple. We see the verdict as being forwarded, but we also see a blocked HTTP request being dropped. So that gives you also troubleshooting capabilities to see what's going on and if needed to take action on that. The best start for understanding flows in your environment is using the Hubble UI. This is an example of a jobs demo namespace. In a given namespace, we have a number of services, and using Hubble UI, you can inspect the connectivity between services, which this information can be used to create effective Cilium network policies for traffic within a namespace. If an application has egress or ingress connectivity, you can also inspect that using Hubble UI. And if you enable layer 7 or DNS aware visibility, you can also see what protocols are being used and also see which fully qualified domain names are being called. So you can make informed decisions what to allow egress and ingress in a given namespace. If you're starting with network policies, I recommend to start with allowing everything in the namespace, but denying ingress and egress, and then use Hubble UI to identify what sources are being reached from an egress point of view, and also what's being exposed from ingress point of view, and if that's allowed, allow that traffic using an additional Cilium network policy. Are there any questions?
The Hubble UI and so on, is that all the open source project, or is that a Sedgeway basically for your commercial part? Is that, or can you elaborate on that maybe?
Yes, very good question. So the Hubble UI is open source, definitely. You can use Hubble UI in open source to see the service dependency map I just shown. This is all available in the Hubble open source. What's in the enterprise release, however, is the ability to read the current applied network policies. So let's say I've created a number of network policies on a given namespace. I get a list of those current applied network policies, so I can see what's already configured, and it will show its related topology. And I can edit it on the fly. For example, if I see a flow which I want to allow, I can, using the UI, I can draft a Cilium network policy, which I can then download and apply through my CI/CD pipeline, for example. Also, features like process visibility in Hubble UI, things like what's it called again? We have, timescape feature, which allows you to go back in time for specific flows, is an enterprise feature. But this basic view you have here is definitely an open source.
So it's an open core model, essentially.
Yes.
Yes. Okay.
Yeah. So I would say already 80% of Hubble functionality using this UI with service dependency maps is already very powerful and ready to use.
Just to comment, Vasu, you can also use it with Gardener today already. And just a question concerning Hubble, as we've seen from our local usage, that it might provide a lot of value, but it is very good at small namespaces with not a lot of content. And if you have a lot of pods and services inside one namespace, it gets hard to understand and figure out the small things. Also, as the traffic is updated in real time, you kind of get lost immediately. Are there any plans to improve that in any way? Because we've seen over the last few releases no real change there.
So you are aware that you can filter on endpoints or services as such?
Yes.
To zoom in into what's going on. Yeah. So already a service map like this one is very complex, right? There's a lot of flows going on already. It's more a question of, I would say, how you would approach securing your workloads. Is it necessary to, from the get-go, do the service-to-service Cilium network policies strategy right away, right? I said, I think earlier, that it's quite hard to start with fine-grained policies from the get-go, because obviously there are a lot of flows going on. I'm not aware of any new improvements going on. I think I'm not sure if it's an open source, but in enterprise release, I do see a aggregate slider, which means that I think it's aggregating similar flows into single flow row, as being shown in this display. But you're right, it can be very noisy in terms of if you have a given namespace with a lot of components, such as this example. The question is more about how you would approach it and how you would secure it. Like I said earlier, I would always start with only securing the namespace, put a fence around a namespace, allowing everything inside a namespace, but not going out or in a given namespace. Because with that, I already have hugely lowered the risk for that given namespace to do something malicious, right? I'm not allowing across namespaces, and I'm not allowing inbound or outbound for a given namespace. And then I would be able to apply a fully qualified domain name visibility, DNS aware visibility policy to see, for example, if the namespace is reaching either to external domains, external fully qualified domain names, or to public fully qualified domain names. And I can make an informed decision if that's allowed. And if allowed, I can create specific Cilium network policies to allow that traffic. And I would look to what's allowed inbound, ingress. Most likely that should be exposed through a load balancer. So I can allow, for example, traffic from ingress inbound to the namespace. And I would like to secure it from a specific source CIDR if possible, and obviously on a port, right? So that already are huge steps in securing namespaces across your cluster before trying even to secure independent services in a given namespace, if that makes sense. Does that make sense?
Yes. Yeah, that makes a lot of sense. Unfortunately, we have a lot of cross namespace communication, but we also already have the network policies in place. I think what we, maybe you come to that later, what we found a challenge was basically, as we used Calico most of the time nowadays, and only started using Cilium a little bit more, we found that the network policies we had in place were not completely compatible, which is a challenge because then traffic gets dropped and you have to figure out why it's getting dropped on the one side or the other.
Yeah, that's hard. Yeah, that's more hard. If you have a Cilium, if it's only Cilium, you can obviously also filter on namespace, name, and you can then only allow, for example, specific IP or specific identity in that given namespace, a specific pod, and most preferably only open a specific port. But if you have multiple CNIs, that becomes more obviously a challenge. So if you could migrate to Cilium CNI, that's obviously powering you to do things more simple in your environment. Okay.
One more question regarding observability. So when we debugged issues in the past, we sometimes had the problem that when you want to check the packet path on a node, it's kind of hard to kind of understand what happens in eBPF, right? Cilium manages all that, which is great on the one hand side. On the other hand side, it feels like you can't really check up, right? In the older implementations, like Calico, you can check the IP tables and follow the packets kind of manually, but it's really hard in Cilium. Now there is this live watch, you can watch the live traffic, but if you don't know how it's supposed to run, it's kind of hard to derive, is there an issue on my node or not? Now, what I'm missing, or what I missed during these debuggings was some tool like a packet tracer on Cisco, so to say, that I can check on a node. Which are the policies I'm running through and what is the outcome of that? And then I can kind of compare it with my expectation. Is there something like that or something planned to get something like that?
We have ongoing development for improving both the CLI as well as have better troubleshooting tools in general, because the eBPF under the hood, it is indeed complex, and that's where I switch off as well. So what the first things I always check is things like Bpf Maps, because that shows the current state. For example, the load balancing Bpf map shows endpoints on a given node, right? So on each node, I can inspect the current state. Also for connectivity tracking is there, right? Or IP cache Bpf maps are there. So I can at least see what's the knowledge on a node level on the Cilium side for that connectivity, or the applied network policies is being tracked as such. So it's not like a full packet trace as such, but at least gives me knowledge about what's currently configured and what the node is aware of at that given point in time. And you may be aware of the sysdump facility as well. The first thing we ask all our customers all the time is, please provide a sysdump, because I think the sysdump is very powerful because it provides a whole picture of your entire cluster, exports it to a zip file, which you can open, for example, in Visual Studio Code, or at least that's how I do it. And then I can do search on error search. I can, on each node, it will create a folder with all the related Bpf maps, and I can quickly check and go across the contents of those files without having to do that on a console, because that takes more time to actually inspect things on a given agent on a given node. So that can by itself, for support issues, it's required. But if you're going to troubleshoot yourself, it will allow you to save a lot of time yourself as well, using a sysdump. I'm not sure if that helps a bit, but that's how I'm doing it.
Yeah, I'll take these tips with me. Thank you.
Cool. I'll take the packet tracing comments as well internally to highlight again that we need to get the right priority or the right resources on that.
Awesome, thanks.
Okay, considering time, I quickly want to go. If you're okay with running over a bit, I want to finish with the service mesh slides, and then we can answer any more questions before we close up. Is that okay?
Yeah, sure.
Good. So Service Mesh, introduced in Cilium 1.12, provides capabilities to provide a sidecar-less service mesh solution for providing ingress, providing traffic management, extending our observability capabilities. So basically what we already can do using Hubble with the observability using eBPF, we can extend that for service mesh. Extend the security capabilities, so not only doing the traffic filtering layer 7 decisions on service mesh, we can also extend network policies with service mesh and provide resilience through high availability, through cluster mesh, through Cilium's resilience on the data plane. You can use Cilium service mesh with the control plane of choice. We are having gateway API on the roadmap for Cilium 1.13. This would enable you to obviously more easily use the Cilium service mesh solution. Out of box, we support an Ingress resource. For advanced users, we support the Envoy CRD. So this hooks back to the question before. Under the hood, Cilium in the agent has an Envoy solution built in. It's not the full Envoy, it's a set of Envoy capabilities we use for layer 7 filtering, but also for the service mesh solution. So for advanced users, if you need to do advanced configuration for service mesh capabilities, such as weighted or percentage-based routing or canary releases, or rollouts, I should say, or things like retries. At the moment, you need to configure this Cilium Envoy custom resource. With Gateway API, we remove that as such. You can extend on the observability piece with providing visibility for tracing using OpenTelemetry or Jaeger, or export metrics to Prometheus and Grafana, or using SIEM solutions or Elasticsearch solutions to see about the data in the service mesh solution. So you have, when you apply Cilium service mesh, you basically have a choice. You either have already an existing Istio-based solution with the sidecar. When you run Cilium with that, you already have some benefits of accelerating the data plane between the sidecar and the destination or source pod. When you start new, obviously, you can have an eBPF native sidecar-free service mesh solution, which has a lot of performance benefits using Cilium service mesh. So obviously, what we try to solve are a number of things. First of all, the cost of sidecar injection. Obviously, when you have an app sending a packet through the service mesh proxy, which again sends the traffic onto the physical network, there's basically 3 TCP IP stacks maintained, and that obviously introduces latency. Using Cilium service mesh, we can shortcut that connectivity right between the app and the proxy using eBPF. That already reduces the latency 4 times. Also, the total number of proxies required is lowered since we bring the service mesh capabilities on the node level as close as possible to the kernel, removing all this requirement for having a pod with a sidecar, and therefore saving a lot of overhead of memory, CPU, TCP IP connections being tracked for each given sidecar. So the eBPF native solution without sidecar, with service mesh, where possible, we provide traffic management for layer 3, layer 4 load balancing, canary rollouts, topology-aware routing, either with or without cluster mesh, security for network policies. MTLS is on roadmap for 1.13. We cannot do that at the moment, but that's on the roadmap. In terms of observability, using eBPF, we can leverage tracing, OpenTelemetry. We can have all the HTTP, DNS, TCP, UDP observability with either Hubble Metrics, and expose them to Grafana to get golden signals for your application and to see how your application is performing, all based on eBPF. When eBPF cannot do it today, and I want to explicitly say today because that's ongoing development as we speak, that means that the layer 7 load balancing traffic management capabilities, the things like retries, the rate limiting, or TLS termination origination, that's currently handled with the Envoy proxy on the node level with Cilium Service Mesh Solution. And more things will be done through eBPF, but at the moment, when we cannot do it right now, we rely on the capabilities of the Envoy proxy embedded in the Cilium agent. I also want to highlight that it is multi-tenant aware, so we make leverage of C groups and kernel namespaces to create listeners of Envoy in specific namespaces, so we have separation of traffic for different namespaces as well. This is a quick graph of showing HTTP latency. So if you have Cilium and Envoy and HTTP filter, we have already 4 times better latency compared to a sidecar-based implementation. And also in terms of visibility, if you enable visibility using eBPF, we have also a lot better performance in terms of latency for that given application. Since we've run out of time, I want to stop here and pause for questions before finishing off. Did that answer the Service Mesh Envoy question?
Maybe not a question, so much of a question, but maybe a thanks, first of all. Very nice to get this overview again, and a reminder for me to try out the already built-in Cilium support of Gardener in Gardener. Mm-hmm. As you heard already, most of our Gardener clusters, at least within SAP at least, are Calico based, and I knew that Cilium was kind of supported, but I was just wondering and touching upon Bill Mulligan's excellent take on open source and the compound interest benefits of open source. I saw that you mentioned a lot of cluster products. What would it take to get Cilium supported also in documentation with Gardener? Yeah, would that be something, you know, we could cooperate with?
Yes,
with the open source project that,
yes,
you know,
we can consider collaborating, providing sections on the Cilium documentation side for Gardener specific implementation.
That would be great, actually.
Yeah. So everyone can contribute, first of all, to Cilium, and that doesn't mean you have to code Cilium features. You can also contribute by providing documentation. Personally, I don't have much experience with Gardener, but we can definitely include Gardener setup guides or best practices or whatever you need on the Cilium documentation side, right? So I'm thinking we already have getting started guides, for example, on RKE2, on on-prem. Perhaps we can create a getting started guide with Gardener as such, right? So
yeah, that would be great. And I think there are a couple of users of open source Gardener in this call as well. And I think that would also enable, I think, more distribution of Cilium in our user base.
Absolutely. So I would encourage and like to invite you to become a contributor of the Cilium OSS community. Yeah. And you can just contribute on the documentation, create a PR for a given page, right? And then someone will review it and add that documentation as such. So I think that's a very good idea. And that's also driven by the community to allow everyone to contribute and to add content. And I think this is very valuable. And as there is more than GKE and EAKS, like Rancher or on-prem, such as Gardener solutions. So yeah, please do. And that's the way. And we can promote that as well. Perhaps we can, that's something Bill can facilitate perhaps as well. Perhaps we can do a live stream or some kind of blog post or content where we explore how Gardener and Cilium is being used in Gardener-based solutions. Absolutely.
That was exactly one of the initial talks we had with Bill earlier on. Let's follow up on that. Okay.
Great. Let's do that.
Thank you very much.
You're welcome. Any other question? No? All right, so let me finish the session with some guidance and pointers to learning more. So on the Isovalent side, we are working on providing more and more labs. These are instruct-based labs. I think they are awesome because they actually spin up an environment where you can run and test either Cilium or Cilium Enterprise. And they are guided labs through scenarios where you can learn about a specific technology, such as subcluster mesh or service mesh or Hubble, in an instruct-based environment. So on isovalent.com/labs, you can test it yourself. We touched upon the OSS community, the Cilium.io website, the docs.cilium.io website. Feel free to have a look there for getting started guides, installation guides, also step-by-step guides on, for example, network policies. Feel free to join the Slack channel for Cilium, so you can ask questions and see news and updates about features as well. If you want to know more about eBPF, please go to ebpf.io for all those resources there. And there's also a great ebook about what is eBPF, written by Liz Rice, our colleague, where she explains in very easy to understand language how eBPF works and why it's so powerful, which gives you the really good basis to understand what it is and empowers you to use Cilium more effectively. With that, I would like to thank everyone for the great questions and an amazing turnout. Thank you for your time and enjoy your day.